Morning, students. Today we are going to discuss about the jet transforms, inverse jet transforms. So up to now we discussed about jet transforms, its properties, okay, and some problems related to jet transforms. Now we are going to discuss about the inverse jet transforms, right? So here, what is meant by inverse jet transform? So suppose, as we already know that jet transform of x of n is x of z. So jet transform of x of n equal to x of z. That is called jet transform. So inverse jet transform of x of z is nothing but x of n. So that is called inverse jet transform. From x of n, we will get x of z. That is jet transform. From x of z to x of n, that is inverse jet transform. So inverse jet transform of x of z is nothing but x of n. So here we have three methods of finding the inverse jet transform methods. Three methods. So three methods to find x of n when x of z is given. So first method is power series method or long division method. Second one is partial fraction method, and third one is residue method. Okay. So first one is the power series method or long division method. It is well known method. It is very popular method. Okay. So from our childhood days onwards, we knew this method, that is long division method, or it is also named as a power series method. See the first model or first method, power series method or long division method. So by solving a simple problem, we can understand the power series method or long division method. So problem is given that x of z is equal to 1 by 1 minus z power minus 1 for mod z is greater than 1, right? This is the given problem. So we will do the long division method for this one. So 1 minus z power minus 1. So it will be multiplied by 1, so that it will get 1 by 1 minus z power minus 1 by subtracting this from this. So we will get 0 plus z power minus 1, and then this will be multiplied by z power minus 1, so that we will get z power minus 1 minus z power minus 2 by subtracting this from the above one. So we'll get 0 plus z power minus 2, and again z power minus 2 into 1, so it is z power minus 2 minus z power minus 3. By subtracting this from the above one, we'll get z power minus 3 and so on. So taking this, so this is x of z equal 1 plus z power minus 1 plus z power minus 2 plus z power minus 3 plus dash 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 plus up to z power minus n. So this is taken as equation number 1. But from the definition of the jet transform, we can write x of z equal to x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2 plus dash 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 plus x of n into z power minus n. That is equation number 2. By comparing these two equations, x of 0 value is 1, x of 1 value is also 1, x of 2 value is 1, x of 3 value is 1, and x of n value is also 1. So all are 1. So x of n equal to 1 into u of n for n is greater than or equal to 0. We can write x of n equal to u of n for n is greater than 0. This is nothing but the inverse jet transform of x of z, given x of z, by using power series method or long division method. Similarly, you can do these problems. So x of z equal to 1 minus 1 by 1 minus e into z power minus 1, so that we can get the solution as x of n equal to a power n into u of n. Similarly, for x of z equal to 1 by 1 plus a into z power minus 1, we can get the solution, that is x of n equal to minus a power minus n into u of minus n minus 1, right? So, and also we can solve this type of problems also by using long division method or power series method, as x of z is equal to z square plus z by z cube minus 3z power minus 2 plus 3z minus 1. Here ROC mod z is greater than 1, right? So z square plus z will be multiplied, will be divided by z cube minus 3z square plus 3z minus 1, so that we can get by multiplying z power minus 1 with z power 3, so that we will get z square minus 3z power 1 plus 3z power 0, that is 3 minus z power minus 1. So that by subtracting this one from the above one, we will get 4z minus 3 plus z power minus 1, since z power 0 is 1. 4z minus 12. Okay, by multiplying 4z power minus 2 with z cube, we will get 4z minus 12 plus 12z power minus 1 minus 4z power minus 2. So that we will get 9 minus 11z power minus 1 plus 4z power minus 2. Again, we multiply with 9 into z power minus 3 z cube. So that we will get 9 minus 27z power minus 1 plus 27z power minus 2 minus 9z power minus 3, except like this, etc. So that we will get x of z is z power minus 1 plus 4 into z power minus 2 plus 9 into z power minus 3 plus 16 into z power minus 4 and so on. So now we will compare it with the definition of the z transform, that is x of 0 plus x of 1 into z power minus 1 plus x of 3 into z power minus 2 plus x of 3 into z power minus 2 and so on, right? So by comparing this, now we will get x of 0 is 0, x of 1 is 1, x of 3 is 4, x of 3 is 9, x of 4 is 16, and x of n is n square. So it is n square into u of n. So therefore x of n equal to n square into u of n for n is greater than or equal to 0, right? This is about the x of n for this problem or this model. So this model is called power series method or long division method. And second one is partial fraction expansion method, or it is also called as PFE, PFE method, partial fraction expansion method. So here x of z is given as 10z by z minus 1 into z minus 2. So we can write this as x of z by z is equal to 10 by z minus 1 into z minus 2. Using partial fractions method, we can write this as a by z minus 1 plus b by z minus 2. A and b can be calculated as a equal to z minus 1 into 10 by z minus 1 into z minus 2 by keeping z equal to 1. So z minus 1 gets cancelled and substitute the value of z equal to 1 in this expression, so that we will get the value of a as 10 by 1 minus 2, that is minus 10, right? In the same manner, we can calculate the value of b as b equal to z minus 2 into 10 by z minus 1 into z minus 2 by keeping z equal to 2. So that the z minus 2 gets cancelled. It is a 10 by z minus 1 and z value is 2. So 10 by 2 minus 1, it is 10. So then x of z by z is equal to minus 10 by z minus 1 plus b value 10 by z minus 2. Now we can write this as x of z equal to z 10z by z minus 1 plus 10z by z minus 2. Are taking 10 as common, minus z by z minus 1 plus z by z minus 2. Okay, we can write this as a 10 into minus 1 by 1 minus z power minus 1 plus 1 by 1 minus 2z power minus 1. 1 by 1 minus z power minus 1 is nothing but 1 plus 1 by 1 by 1 minus 2z power minus 1 is nothing but 2 power n. So we can write this as x of n equal to 10 into minus 1 plus 2 power n into u of n. Okay. So it is the inverse Z transform by using partial fraction expansion method. That is the second one. And also determine x of n using partial fraction expansion method, that is x of z equal to 2z square by z plus 1 into z plus 2 whole square. So we can write this as x of z by z is equal to 2 into z by z plus 1 into z plus 2 whole square, r which is equal to a by z plus 1 plus b by z plus 2 plus c by z plus 2 whole square, right? C by z plus 2 whole square. So a can be calculated as z plus 1 into 2z by z plus 1 into z plus 2 whole square by keeping z equal to minus 1. So z plus 1 gets cancelled. It is 2z by z plus 2 whole square by substituting value of z equal to minus 1 here. So that we will get minus 2 by 1, it is minus 2. A value is minus 2. And how to calculate b value? B value equal to d by dz of z plus 2 whole square into 2z by z plus 1 into z plus whole square by keeping z equal to minus 2. Here z plus 2 whole square and z plus 2 whole square gets cancelled. It will become 2z by z plus 1. This is in the form of u by v formula. So v square into u into d by dv of v minus v into d by dv of u. Okay. So that we'll get the value of v is 2. And c value is z plus 2 whole square into 2z by z plus 1 into z plus 2 whole square by keeping z equal to minus 2. So z plus 2 whole square, z plus 2 whole square gets cancelled. 2 into minus 2 by minus 2 plus 1. So minus 4 by minus 1, it is 4. Okay. So therefore x of z by z is equal to minus 2 by z plus 1 plus 2 by z plus 2 plus 4 by z plus 2 whole square. Okay. Or we can write this as x of z equal to minus 2 into z by z plus 1 plus 2z by z plus 2 plus 4z by z plus 2 whole square. As we already know that z transform a for n into u of n is z by z minus a. But it is given as z by z plus 1 is z by a is 1. Then it is a for n into u for n. Okay. That is minus 1 whole for n into u for n. Okay. Similarly, n into a for n, u for n, u of n. Z transform this one is a z by z minus a whole square. Okay. So that is minus 2 whole power n. Z transform minus 2 whole power n is z by z plus 2, and n into minus 2 whole power n is z transform is minus 2z by z plus 2 whole square. Okay. Then we can write taking inverse z transform on both sides, we get the inverse z transform of x of z equal to 2 into inverse z transform of z by z plus 1 plus 2 into inverse z transform of z by z plus 2 minus 2 into inverse z transform of 2z by z plus 2 whole square. So minus 2 into minus 1 whole power n. Okay. Plus 2 into minus 2 whole power n. Right. Minus 2n into minus 2n into minus 2 whole power n. That is the inverse z transform of the given function for n is greater than or equal to 0. So we can write this as 2 into minus 1 whole power n plus minus 2 into whole power n minus 2 power n minus n into minus 2 whole power n. So that is the second method. What is that? Partial fraction expansion method. Second method is partial fraction expansion method. And third one is residue method, or it is also called as inverse integral method. Okay, residue method or inverse integral method. So given from x of z equal to n of z by 10 into z by z minus 1 into z minus 2, right? 10 z by z minus 1 into z minus 2. Okay. So the discrete time sequence x of n can be obtained from its z transform by using inverse integral method, or it is also called as residue method. Inverse integral method or residue method. So x of n, that is residue. Inverse integral method can be expressed like this, that is x of n equal to 1 by 2 pi j integral x of z into z power n minus 1 dz, right? X of n equal to 1 by 2 pi j integral x of z into z power n minus 1 into dz. Let x of z into z power n minus 1 be g of z. Okay. Then this integral will become x of n equal to 1 by 2 pi j integral g of z into dz. So it is nothing but sum of residues of g of z corresponding to poles of g of z. Okay. Sum of residues of g of z corresponding to poles of g of z. So given problem is x of z equal to 10z by z minus 1 into z minus 2, right? Okay. So first of all, we will write g of z as x of z into z power n minus 1, right? Here, g of z equal to x of z into z power n minus 1. So what is x of z given 10z by 10z by z minus 1 into z minus 2 into z power n minus 1. So we can write this as a 10 into z power n by z minus 1 into z minus 2, right? Here, g of z contains poles at z equal to 1 and z equal to 2. Therefore, x of n will become residue of g of z at z equal to 1 plus residue of g of z at z equal to 2. That can be represented as r at z equal to 1 plus r at z equal to 2. How to calculate these residues? So in general formula, suppose r at z equal to a can be calculated as z minus a into g of z at z equal to a. Okay, z minus a into g of z at z equal to a. Similarly, R residue at z equal to 1 can be calculated as R at z equal to 1 is z minus 1 into g of z at z equal to 1. So z minus 1 into g of z is 10 into z power n by z minus 1 into z minus 2 at z equal to 1. So z minus 1 gets cancelled. So it is 10 into 1 power n by 1 minus 2, that is minus 10. Similarly, residue of g of z at z equal to 2 can be calculated as R at z equal to is equal to z minus 2 into g of z at z equal to 2. Okay. Mm. So z minus 2 into 10 into z power n by z minus 1 into z minus 2 by keeping z equal to 2. Okay. Z minus 2, z minus 2 gets cancelled and substitute value of z equal to in that expression. So 10 into 2 power n by 1, that is 10 into 2 power n. Okay, so then x of n equal to sum of the residues, that is r equal to 1 plus r at z equal to 1 plus r at z equal to 2. So r at z equal to 1 value is minus 10 and r at z equal to value is 10 into 2 power n. So it is minus 10 plus 10 into 2 power n for n is greater than or equal to 0, or we can write this as 10 as common 2 power n minus 1 into u of n. Okay, that is the inverse the transform of the given function x of z equal to 10 z by 10 z by z minus 1 into z minus 2. Okay, next second problem is x of z equal to 3z minus 1 into z by 2 into z minus 1 whole cube. So what is x of n? X of n equal to 1 by 2 pi j into integral x of z into z power n minus 1 dz, right? But let x of z into z power minus 1 n minus 1 is nothing but g of z. So we can write this as 1 by 2 pi j into integral g of z dz. Okay. So some of the residues of g of z corresponds to poles of g of z. So it is g of z equal to x of z to power n minus 1. So x of z is 3z minus 1 into z by 2 into z minus 1 whole cube into z power n minus 1. So that it will become 3z minus 1 into z power n by 2 into z minus 1 whole cube. Or we can write this as 3 into z power n plus 1 minus z power n by 2 into z minus 1 whole cube. 2 into z minus 1 whole cube. See, g of z contains a third order pole at z equal to 1. Since it is z minus 1 whole cube, then it is a third order pole. Numerator polynomials are zeros and denominator polynomials are poles. Okay, so this is third order pole at z equal to 1. Then x of n equal to residue of g of z at z equal to 1, that is third order pole. Here x of n equal to r at z equal to 1, then brackets you write third order pole. Suppose here is a formula is there for mth order pole r equal to r at z equal to a, then we express it as d power m minus 1 by dz power m minus 1 into z minus a whole power m by m minus 1 factorial into g of z at z equal to a for m order pole. Here m is given as 3. So then residue at z equal to a will become d 3 minus 1 by dz power 3 minus 1 into z minus a whole cube by 3 minus 1 factorial into g of z at z equal to a. So it is d square by dz square z minus a whole cube by 2 factorial, that is 1 into 2, that is 2 into g of z at z equal to a. Here g of z is 3 into z power n plus 1 minus z power n by 2 into z minus 1 whole cube at z equal to 1. Z minus 1 cube and z minus 1 whole cube both gets cancelled. So it will become d square by dz square of 3 into z power n plus 1 by z power n by 4. Okay, it's z equal to 1. So it is 1 by 4 into d by dz of 3 into n plus 1 of z power n plus 1 minus 1, that is z power n minus n into z power n minus 1, right, at z equal to 1. Again we will do the differentiation for this one, 3n into n plus 1 into z power n minus 1, and it is n into n minus 1 into z power n minus 2 at z equal to 1. Now substitute the value of z equal to 1 in this expression, 3n square plus 3n into 1 power n minus 1 minus n square minus n into 1 power n minus 2. So it will become 1 by 4 into 2n square plus 4n, or we can write this as 0.5 n square plus n. So x of n equal to 0.5 n square plus n whole into u of n for n is greater than or equal to 0. 0.5 n square plus n whole into u of n for n is greater than or equal to 0. So that is about the residue method. Like that, we have three methods of finding the inverse jet transform. First one is power series method or long division method. Second one is partial fraction expansion method, and third one is residue method. Residue method or inverse integral method. Okay. So this can be already solved in the previous classes. This problem can be solved, and here also cos and omega, a for n sin and omega. These also can be solved. Okay. This I am concluding the today's class. Thank you.